Hello and welcome. We are Group 5 of Chemistry 3L and today we are presenting you a tutorial of MarvinSketch.
As students in organic chemistry and future chemists, learning how to use a molecular modeling software is of utmost importance.
There are several modeling softwares available to us, but today we will be exploring MarvinSketch by ChemAxon, which is a Java-based chemical digital drawing tool that allows users to create, edit, and save molecules in various file formats.
MarvinSketch features a wide set of functionalities that enable users to draw chemical compounds promptly and accurately. It also supports the widest range of industrially acknowledged standard chemical file formats.
So, are you ready? First, let us learn how to install MarvinSketch. First, go to chemaxon.com/products/Marvin and there create a free ChemAxon account. Once done, click the download button and you will be sent to a new window. Click the download button that shows up on the screen.
Place the file in an easy-to-find folder, although by default it can be found in the Downloads folder. And once the file has finished downloading, open it and click on the Run option. From there, the program will begin installing the Install 4J wizard. This will guide you through the installation process.
Once the wizard has been installed, a new window will pop up. Click the I accept the terms and conditions defined in the EULA box and click Next. Click the standard installation option and click Next. This will now start to install MarvinSketch on your device. Once installed, a new window will pop up. Click Finish to exit the wizard and complete the installation process.
When you open the application, it will ask you for a license. Close the application and go to chemaxon.com/products/Marvin/download. Scroll down and select the Non-Commercial Use tab. Click the Accept and Terms and Conditions box and then click Get My Key. You will be sent to a new window. Click on Copy Key.
Open MarvinSketch and click on Install Licenses. Go to the License Server Configuration tab and paste the key we copied. Click Test to double-check the key, then it should say Successful Connection. Click Apply, then it should say that settings are saved and that you might need to restart running applications.
Close MarvinSketch and open it again. The application should run by now. There will be shortcuts on your desktop for both MarvinSketch and MarvinView. You may also access them by going to your local disk drive and selecting the Program Files folder, then the ChemAxon folder, and finally the MarvinSuite folder.
Congratulations! You have successfully installed MarvinSketch. Now let us start learning it by exploring its many functions and features. Located on top of the software are the menus. The first one is File. It contains available file operations like New, Open, Save, and etc. Next is Edit. This contains clipboard operations like copy, paste, and Marvin-specific editing options. Next is View, which can be used to alter the display of the molecule on the canvas. It also contains options to change the graphical user interface. Next is Insert, which allows you to draw structure templates, bonds, text boxes, and more on the canvas. Next is Atom, which contains all atom-related properties like charge, maps, and more. Next is Bond, which allows you to change the type of bond and contains bond properties such as topology, reacting center, and etc. Next is Structure, which provides chemical functions relating to structures such as aromatization, naming, and etc. Next is Calculation, where you can see all available calculator plugins. Next is Services. And lastly, Help, which provides information about using the program, details, license management, and more.
The majority of the screen is covered by the canvas, the canvas main area where chemical structures, queries, and reactions are drawn and edited. To zoom in or out of the canvas, hold Ctrl and use the mouse wheel. You may also use the zoom buttons on the general toolbar, or specify the zoom percentage by using the drop-down list or navigating to view and then zoom level. To scroll the canvas, you may click the scroll arrow of the scroll bar, drag the scroll bar or use the appropriate arrow keys. To move the canvas, hold Shift or use the mouse wheel or use the arrow keys, but these only work when there is no selection made or everything is selected. Otherwise, use Ctrl plus arrow keys or Shift plus arrow keys to move the selected items in greater units.
The buttons for frequently used commands can be found in the general toolbar. The tools that can be found here are rectangle selection, lasso selection, structure selection, the three of which allows you to move particular objects on mouse drag. We can also erase, undo, redo, copy, paste. We can even check structure, zoom in, zoom out, the actual zoom tool, and help contents.
The basic elements for drawing structures such as bonds, chains, graphics, etc. can be found on the leftmost side. To place various bond types on the canvas, click Insert Bond. If you want to place a carbon chain on the canvas, click Insert Chain. To turn the bond into a wedge, use the Bond tool. Or if you want to turn them to be dashed, use the Hash Bond tool. Insert Text allows you to place a text object on the canvas. If you want to change an atom label on the canvas, you may use the Atom Label Editor. Straight Arrow, Reaction, and Atom Map allows you to place various reaction arrows on the canvas. Create Group creates a custom abbreviation group. Insert Brackets places brackets, parentheses, or braces on the canvas. While Insert Graphics places various graphical objects on the canvas. Finally, we have Increase Charge and Decrease Charge, which increases or decreases the charge of the selected atom. The number of hydrogens will be adjusted if possible to accommodate the new charge. Valence errors are highlighted in red.
The rightmost side has the atoms, which contains the periodic table and the most frequent atom types. The periodic table shows a table and atom property drawing window. You can also insert hydrogen, carbon, nitrogen, oxygen, sulfur, fluorine, phosphorus, chlorine, bromine, and iodine atoms on the canvas.
Finally, down the canvas, we can see the advanced templates, which contain some of the several structure templates in drawing organic molecules. We can also see the status bar, which shows file status, navigation buttons, and dimension button. It appears at the bottom of the frame and cannot be customized or moved. Here we can see the dimension buttons to switch between 2D and 3D modes. The file status indicator, which shows if there are unsaved modifications. The navigation buttons, which allows you to navigate between pages on multi-page molecular documents. And the structure check status, which displays different images for different statuses, but is disabled by default. To enable manual checking, double-click it, and for automatic checking, right-click it.
Hopefully, we are now familiar with the different features and functions of MarvinSketch. Let us now continue by performing some tasks on the software.
To start, Let us begin by constructing some molecules. Let us take ethyl sodium, which has the molecular formula of CH3CH2Na. To construct ethyl sodium, first create a propane parent chain. Then put a sodium atom on one of the ends.
Great! Let us keep that momentum going by constructing another molecule. This time, let us try to draw 3s3-methylhexane and 3r3-methylhexane. To construct this molecule, first create a hexane parent chain. To construct the 3r configuration, put a single up bond on the third carbon. To construct the 3s configuration, create another hexane parent chain and put a single down bond on the third carbon.
Amazing! We will teach you one last molecule to make before we move on. Let us attempt 2e-pent-2ene and 2z-pent-2ene. To construct this molecule, first create a pentane parent chain. To construct the 2e configuration, put a double bond on the second carbon. To construct the 2z configuration, create a propane chain and add a double bond on the second carbon. Afterwards, add another carbon chain on the third carbon. This chain should point upwards. Finally, add another carbon chain on the fourth carbon. This chain should point to the right. To double check your structures, click on the Structure menu and select Structure to Name. A pop-up will appear and click OK. A new pop-up will appear showing you the traditional and preferred IUPAC names along with the respective structures.
That will be all for now. Later on, we will be teaching you how to make 2 more molecules that we will be using in performing tasks in MarvinSketch. I hope you are still with us. Let us continue. Let us continue learning how to use MarvinSketch by performing some specific tasks. First, let us construct a molecule that we will be using in performing these. Let's use salicylic acid. To construct the salicylic acid, first click the Structure menu, and then select the Name to Structure option. Type salicylic acid, and then press Import. The structure of salicylic acid will then appear on the canvas. To construct the molecule from scratch, first, put a benzene ring and then add a single bond on the first carbon. Then, add an oxygen atom at the end of a double bonded carbon chain to the right, and another oxygen atom at the end of a single bond to the left. Finally, add another oxygen atom at the end of a single bond to the carbon to the left of the first carbon.
Great! Now that we have our salicylic acid, let us attempt to learn how to view the 3D structure of a molecule using it. First, select the molecule and click View. Go to Editor Style and click View Mode, then open Marvin View 3D on the menu bar. Go to View, then Display, then Ball and Stick, and there you go! You can now see the 3D structure of your molecule. To go back, just go to View, then Configuration, and click Marvin.
Let us go back to our salicylic acid. Let us now try to learn how to get the name of a molecule from its structure, and vice versa. To get the name, select the molecule, go to Structure, and click Structure to Name. Then click OK. To get the structure from the name, you may use a keyboard shortcut, Ctrl-Shift-N, or go to Structure again and click Name to Structure. Enter the name and there you go.
If we want to see the lone pairs on the heteroatoms of a molecule, this is how you can do it. First, go to View, then Advanced, then Enable Lone Pairs. We did it! We can now see the lone pairs of the heteroatoms of salicylic acid.
Now, let us get a benzene together with our salicylic acid. Let us learn how to see the aromatic form of a benzene. First, go to Structure, then go to Aromatic Form. Then, click Convert to Aromatic Form. There you go. It's that simple.
Let us now head into more specific tasks. Say we want to show the absolute configurations of stereocenters. This is how we can do so. For chiral centers, let us take free methylhexane, let us go to View, then Stereo, then R/S labels, and enable all possible.
For alkenes, let us use 2-pentene. We will do the same first steps, but instead of going to R/S labels, we will enable E/Z labels.
Let us now learn how to construct another molecule. For this, we will be using alanine. To construct alanine, first click the Structure menu and then select the Name to Structure option. Type alanine and then press Import. The structure of alanine will then appear on the canvas. To construct the molecule from scratch, first create a propane-carbon chain like this. Next, put a single bond with a nitrogen atom at the end of the second carbon. Finally, add an oxygen atom at the end of a single bonded carbon to the right of the third carbon, and an oxygen atom at the end of a double bonded carbon to the left.
Using the alanine we just constructed, let us learn how to generate the different physico-chemical information about the molecule. First, select the molecule and go to Calculations. Then click Elemental Analysis. Check which applies and then click OK. To get the pKa of the molecule, we go to Calculations again, then Protonation. Click pKa, select and enter those that apply, then click OK. Going back to the calculations and protonation, we can also get the isoelectric point. Select and enter those that apply, then click OK. Lastly, we can get the H-bond donors and acceptors by going to Calculations, then Other, and H-bond donor/acceptor. Again, select and enter those that apply, then click OK.
We can also use MarvinSketch to show the electron flow in a homolytic and heterolytic cleavage. To indicate the electron flow in a homolytic cleavage, go to Insert, then Electron Flow, then click one electron. Start from the bond, then drag it to the atom. Do this to the other atom. For heterolytic cleavage, do the same first steps but click 2 electrons instead. Then drag it from the bond to the appropriate atom.
The last thing that we will be teaching you today is how to show that one of our carbon atoms is carbon-14. Take the ethyl sodium that we constructed a while ago. First, select the carbon atom that you want to indicate, then go to Isotope, then choose carbon-14. And now, it is shown as a carbon-14 atom. That wraps up our video manual for MarvinSketch. We hope that you learned a lot from this video tutorial, and we hope that you can use and apply it as you learn organic chemistry. We are very lucky that these tools are available to us to make our learning easier and better.
Before we end, let us recap what we have learned throughout the video. First, we introduced you to and taught you how to install MarvinSketch in your device. We also explored the several features and functions of the software, like menus, toolbars, the canvas, drawing elements, atoms, and advanced templates.
We also learned how to construct 5 molecules, 3s3-methylhexane and 3r3-methylhexane, 2e-pent-2-ene and 2z-pent-2-ene, salicylic acid, alanine, and ethyl sodium. These are the timestamps for the construction of these molecules.
We also taught you how to perform specific tasks in MarvinSketch, like viewing the 3D structure of the molecule, getting the name and structure of a molecule from each other, showing the lone pairs of heteroatoms, displaying the absolute configuration of stereocenters, generating physico-chemical information, showing the electron flow in homolytic and heterolytic cleavage, showing the aromatic form of benzene, and showing that one of our carbon atoms is C14. These are the timestamps for those specific tasks.
That will be all for today. Again, we are Keonah Bueser,
Deric Gullon,
and Maralit.
Kyle Ramos,
and Jose Suba from Chemistry 3L. We hope that you enjoyed our tutorial. Thank you very much.